A high-performing workforce is necessary to successfully land an aircraft carrier. Every navy in the world has received extensive training in the skill of landing on a surface no larger than a postage stamp. A carrier landing is equivalent to a controlled crash when compared to conventional runways. The majority of other aircraft can be destroyed by the impact. One of the most challenging tasks as a Navy pilot will ever have to complete is landing on the flight deck. A routine landing on March 18, 2016 quickly turned into an emergency. An E-2C Hawkeye made the landing on the aircraft carrier USS Eisenhower, but as it approached the end of the runway, its tailhook hooked the arresting wire and it appeared as though it wouldn't stop. Eventually, the cable snapped, sending the Hawkeye careening off the flight deck and toward the water. Therefore, why did the wire break? In order to respond to it, it is necessary to examine the operation of a standard aircraft arresting system, which consists of three main parts: the arresting cable, the purchase cables, and the arrest sync engine. Welcome to another episode brought to you by High Technology. If you are new to this channel, be part of us by subscribing so you won't miss any future contents. Today, we're going to look more closely at these emergency landings in this video. Before we continue, just a reminder to give this video a thumbs up. Returning to the emergency landing on an aircraft carrier's flight deck, starting with the arresting cable. The cross-deck pendants, also known as arresting cables or arresting wires, are flexible steel cables extended over the landing area. Since the tailhook of an incoming aircraft captures these cables when it lands, the arresting cables are the first line of defense for the arresting system. Aft to forward arresting cables aboard aircraft carriers are numbered 1 through 4. The arresting cables must be both flexible and sturdy given their role. Because of this, they are fashioned of wire rope with a 1 to 1.5 inch diameter. Each wire rope is constructed of a number of steel strands wound around a center core of oiled hemp, which serves as a cushion for each strand and lubricates the cable on American supercarriers. The arresting cables are changed considerably more frequently than I would have anticipated. Every 125 arrested landings. As a result, the cable's two ends are fitted with termination couplings, made for rapid separation. To make it simpler for the tailhook to snag the wire upon landing, it would take 2 to 3 minutes to switch the arresting cables on an aircraft carrier. On carrier-based systems, the arresting cables are raised several inches by curved steel leaf springs that are placed on top of the cables. These springs can bend over the flight deck to allow the airplane to taxi over the cables. Next is the purchase cable. The arresting cable and the buy cable are both wire ropes. However, the purchase cable has a different function. The buy cable has two ends, one of which is connected to the arresting cable and the other to the arresting gear engine. The purchase cables are likewise pulled out as the airplane pulls on the arresting cable. Payout is the process of sending an aircraft's landing force through the purchase cable to an engine that is at rest. The purchasing cables are not only changed less frequently than the arresting cables, but they are also significantly longer than the arresting cables. Lastly, we reach the arresting engine, the beast's brain. The arresting engine's role is to slow down and stop the aircraft by absorbing its landing force. The mechanics of the arresting engines are both highly intriguing and comprehensible. There is a ram in the cylinder below the flying deck. The purchase cables wind around a set of sheaves on either end. The ram is supposed to be driven into the cylinder when the incoming aircraft catches and pulls the arresting cable, which then pulls the purchase cable. Hydraulic fluid is used to fill the cylinder, which is connected through a control valve to a piston-style accumulator. Compressed gas is present on the accumulator piston's opposite end. The non-return valve merely prevents the gas pressure in the accumulator from forcing back the fluid and the ram when it's time to reset when an aircraft hooks the arresting line and drives the ram into the cylinder, allowing fluid to flow through the control valve and into the accumulator. Bypassing the one-way valve, which resets everything to its initial positions, the reset valve is open. But the control valve, which effectively controls how much hydraulic fluid goes from the cylinder to the accumulator, is what helps in absorbing the momentum of the landing aircraft, is a crucial component of this system. As the landing aircraft pulls the purchase cable out, a barrel with a series of grooves on it is within the control valve. Additionally, the barrel is moved, exposing the groove's narrower side and raising the fluid's resistance to flow. As a result, the payout of the purchase cable will gradually slow down and then halt, bringing the airplane airplane to a complete stop. This is how the arresting engine and the entire arresting system function. The general procedure is comparable to what we outlined, even though more contemporary arresting systems might operate a little differently. The purchase cable can now break if it stops paying out for any reason while the aircraft is still moving too quickly, which is exactly what occurred to the Hawkeye. The arresting cord eventually gave way because the miscalibrated engine was unable to absorb the energy in a way that would allow it to do so. Let's go back to the control valve. The grooves on the barrel are not all the same width, so the starting position of the barrel needs to be carefully chosen based on the weight of the aircraft. But wait, different aircrafts have different weights. How does the arresting engine account for different aircraft with varying weights? In order for the arresting mechanism to be adjusted appropriately, an officer in primary flight control must give the arrestor operator the weight of the landing aircraft. It's also important to note that the Hawkeye did not collide with the water. The pilot and co-pilot did, in fact, get the military's highest honor for preserving the aircraft. But on the flight deck, things were very different. Because of incidents like this, the flight deck crew is trained to not turn their back on a landing aircraft, especially when a split second can mean the difference between surviving or not. The snapped wire swung across the flight deck, hitting 8 sailors and inflicting injuries ranging from minor lacerations to broken bones and a cracked skull, but fortunately no fatalities. It's important to remember that not all aircraft carriers have arresting systems. On the ground, they are also present. However, there are some distinctions between carrier-based and land-based arresting systems. For instance, land-based arresting systems raise the wire off the ground instead of using a bi-cable by using donut-shaped rubber supports. Land-based systems use a comparable tape that may be purchased and is composed of thick nylon. 2 arresting engines are typically used in land-based systems, one on each side of the runway. The airplane is slowed down and brought to a stop by the braking force the arresting engines apply to the reels holding the purchase tapes. Usually placed in Air Force facilities, these land-based arresting systems allow for emergency landings caused by brake problems. In order to maintain these systems, pieces of the purchase tape that have come into contact with the weather are cut off, and the tape clamp is then reattached to the fresh end of the tape. What do you think of this amazing Navy equipment? Let us know in the comments. That's it for today's video. Thank you for watching. If you enjoyed this content, please don't forget to like and hit the subscribe button and the notification bell so you can always get to watch more incredible videos like this. This has been High Technology, serving you the best and cutting edge contents on the highest form of technology available on the planet. Until then, see you!